Okay, so in this video we're going to look at why sine of 90 degrees plus or minus theta is equals to cos of theta, or why cos of 90 degrees plus or minus theta is equals to plus or minus sine of theta. So how are we going to find out? We're just going to use this Cartesian plane over here. So the first thing we're going to do is let's establish these angles, right? So let's establish angle theta. Let's find the trig ratios of theta. So the first thing we're going to do is write sine of theta, which is equals to, so looking at the diagram of theta, sine of theta is opposite, which the opposite side is x and the hypotenuse side is r, right? So it's going to be x over r, right? And then let's establish cos of theta. It's going to be cos of theta is equals to, so the adjacent side is your y for the theta and the hypotenuse side is r. So it's going to be y over r, right? Then let's establish tan of theta. It's going to be tan of theta is equals to, so the tan of theta, it's the opposite side, which is your x, and the adjacent side, which is your y. So it's going to be x over y, right? So now we've established the sine of theta, the cos of theta, and the tan of theta. Now let's establish this angle here, which is 90 degrees minus theta. The same trig ratios. So the first thing we're going to do is we're going to find the sine of 90 degrees minus theta, right? So 90 degrees minus theta is, we know very well that it's opposite over hypotenuse. So it's, the opposite side is y. So it's going to be y over the hypotenuse side is r, right? So then we're going to find cos of 90 degrees minus theta, which is equals to, so 90 degrees minus theta, the adjacent side is this x here and the hypotenuse side is r. So it's going to be x over r, right? Then we want to find tan of theta, or sorry, tan of 90 degrees minus theta. So it's going to be tan of 90 degrees minus theta, right? So it's equals to, then the opposite side is your y and the adjacent side is your x, right? So it's going to be y over x, right? So now we've identified our trig ratios, right, using these both triangles. So I want you to notice something here. So we're having sine of theta, right, which is x over r. And looking at this side here, we are going to see that this cos of 90 degrees minus theta, it's also equals to x over r. So basically, when you find the reduction formula for cos of 90 degrees minus theta, it will give you sine of theta. So this proves that it will actually gives you sine of theta. Why? Because you are getting the same values here. So because of these same values here, or this same ratio, that means that when you change cos of 90 degrees minus theta, you're going to get sine of theta. Then we have a look at another one, which is this one here, y over r. Which one is y over r on this side? It's this one here. So basically it tells us that if you're gonna reduce sine of 90 degrees minus theta, which is equals to y over r, you're gonna get cos of theta, right? So this basically proves that when you reduce sine of 90 degrees minus theta, you will get cos of theta. Then we go to this one here, which is tan of theta, right? So because it's tan, so really it's just going to remain the same. So it's tan of theta, which is x over y, right? So which basically tells us that for tan of 90 degrees minus theta, we're having y over x. So for the solution, which means now that this y is going to be our denominator and x will be the numerator, but we're not really interested in these in this trig ratio. We're mostly interested in the sine of theta and the cos of theta. So now you've noticed that the sine of 90 degrees minus theta will give you cos of theta, and the cos of 90 degrees minus theta will give you sine of theta. So now we are to find out why sine of 270 degrees plus or minus theta gives us plus or minus cos of theta, or why cos of 270 degrees plus or minus theta gives us plus or minus sine of theta. So as you can see here, my Cartesian plane, I drew two triangles that represents two angles, right? One represents 270 degrees minus theta, and the other one represents theta, right? So let's first start with the one that represents theta. Let's find the trig ratios for that one. So the first thing is we're gonna find sine of theta. Sine of theta, the opposite is your x and the adjacent side is your r, right? So it's going to be your x over r for this one, and then you want to identify your cos of theta, which is equal to the adjacent side is your y and your hypotenuse side is your r, so it's going to be y over r. And then we want to find the tan of theta, which is equals to the opposite side, which is your x, and your adjacent side, which is your y. So it's going to be x over y, right? Fine. So now we've identified the trig ratios using the theta. Now let's find trig ratios using your 270 degrees minus theta, right? So the first thing you're going to do is you're going to find your sine of 270 degrees minus, so let me write it nicely, 270 degrees minus theta, right? So according to this diagram here, the triangle, the opposite side is your y, so it's equals to your y over your hypotenuse side, which is your r, right? And then you want to identify cos of 270 degrees minus theta, right, which is equals to, so the cos, which is the adjacent side of the angle, it is your x, and then your hypotenuse side is r. Then we identify your tan of 270 degrees minus theta, which basically means that it's the opposite side, which is your y, and your adjacent side, which is your x. Opposite side, which is your y, and x, like that. So now you're going to compare which trig ratios are the same. So looking at this one here, sine of theta, it's equals to x over r. So in the other side, which one is equals to x over r? It's cos of 270 degrees minus theta. So it means now that if you were to find an answer for cos of 270 degrees minus theta, you're gonna get sine of theta. Then let's look at another one, which is y over r, this one here. Which other trig ratio is y over r? It's this one here, right? So basically, if you are going to find the sine of 270 degrees minus theta, you're gonna get cos of theta. Then these ones here, it's just tan of theta, which is x over y in this case, and then here it's y over x, right? So we're not going to focus much on these ones here, but now you've noticed that if you're going to find the reduction of 270 minus theta, then you know very well that the sine of 270 degrees minus theta gives you cos of theta, and the cos of 270 degrees minus theta gives you sine of theta. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comment section below. Don't forget to subscribe to the channel for more videos.